So I want to talk with you here about what's called the change of base formula with logarithms. It's basically a nice way to be able to write a log in a particular base as a log in any other base. That's why we call it the change of base formula. And I'll just hop right into it. It looks like this. If you've got a logarithm of any base of any number, as long as that log exists and is defined, you can switch it to any other base by setting up this fraction. So choose a new base and just do the log of the inside number on the top divided by the log of the base number on the bottom. Here's where this is most helpful. So you've got your Desmos, you've got your handheld calculators, and most handheld calculators now can easily handle logs of different bases. However, a lot of you use scientific calculators, which are great, but they often don't have a particular button that lets you do a log in any base you want. You have pretty much just that log button, the common log to base 10. Fear not and worry not. We can evaluate these logs using that button. So for example, let's not forget what logs give us. They give us exponents. So what we have is, what exponent did we put on 8 to get 64? Well, it's 8 to the second power. So this logarithm should end up being 2. Let's get that same 2, though, using the change of base formula. Now, when we're choosing this new base, we're going to choose base 10 because that's the button we have on our scientific calculators. So if I evaluate log base 10 of 64 and then divide that by the log base 10 of 8, I should end up with this same number 2. So let's just make sure that happens. Pulling up our calculator here. So if I do log of 64 divided by log of 8, what we're looking for is the number 2, and right there it is. Just for practice, I would like you to use the change of base formula. So even if your calculator has the fancy log of any base buttons, just for practice, would you evaluate this next logarithm? Do a quick pause, unpause when you are ready to check. So we're going to evaluate log of 20 divided by log of 4. Now we know it's going to be some number between 2 and 3 because 4 to the second power is 16, which is below 20. 4 to the third power is 64, which is above 20. So somewhere between 2 and 3, probably closer to 2. Let's now go here to the calculator. Let's do log of 20 divided by log of 4. And let's round that to 3 decimal places. So 2.161. Okay, so approximately 2.161. And then just to verify that that is in fact the case, if I take 4 to this power, I should get 20. So 4 to the power of 2.161. Now, because I rounded this, it's not going to be exactly 20, but it should be close. Sure enough. So that works out okay. And then once more, just for practice, please evaluate that bottom logarithm. Okay, so make sure you get your numbers in the right spots. It's always log of this inside number divided by then the log of the base number. And this one, again, is going to need to be rounded. That's a 6 down there. Ooh. So 2.354 and 0.86. So log 2.354, 0.86. You can put the 0 in, it doesn't make any difference there. Okay, so negative 5.676. I hope the negative at least makes a little bit of sense. I've already forgotten. Was it 676? Yeah. And the reason I hope the negative makes sense is because 0.86 is a fraction less than 1. So if the result is going to be a number bigger than 1, I've got to at some point flip that fraction upside down, right? When you're raised to a power, negative exponents are what make that happen. So just a quick check, make sure this works out okay. If I take 0.86 to the power of negative 5.676, I should get something very close to 2.354. Oops, there we go, 2.354. Notice it's a little bit off. That's because we rounded, but it is pretty close. Oh, and I left my second 6 off there. So tell you what, just for, get that 6 in there. There we go. 2.35, that's a little bit closer. So there you go, the change of base formula.